Okay, welcome to the third lecture of the first week of MFP 510. If you're watching this video, then you've made it through the first two and you're ready for more. So what I want to do now is basically do the same thing I did in the previous video, but now solve a min problem. So I've got one for us. So in this, come on. There we go. There we go. All right. So we want to minimize 12x1 plus 42x2 subject to x1 plus 2x2 is greater than or equal to 3. X1 plus 4x2 is greater than or equal to 4. And then 3x1 plus x2 is greater than or equal to 3. And of course, x1, comma, x2 are greater than or equal to 0. All right? So same thing as before. Okay. Here, of course, is our x1 axis. Here is our x2 axis. And we want to start drawing our constraints. So I'm going to do the same thing I did in the previous lecture. Solve all of these constraints individually for x2. So I'm going to take the first one. So I'm going to have 2x2 is greater than or equal to 3 minus x1, right? Or x2 is greater than or equal to 1.5 minus 0.5 x1, right? 3 divided by 2 is 1.5, and 1/2 x1, right? So here, again, these are just going to be lines. So go to 1.5, and I got to make sure, okay, so I'm actually going to put 1.5 right here, okay? And I've got to take this thing down to 3, right, because my slope is a -1. I'm sorry, slope is a -1/2. So I'm going to take this guy down to 3. And so, voila. Now notice, this is greater than or equal to, right? So, draw. Let's just go with yellow for the first constraint, right? So yellow. Okay. And there. So first constraint is yellow. Okay. Now let's go back, get my pen, get rid of this, and do the same thing for the second constraint. Okay, solving for x2, right? So I'm going to have 4x2 greater than or equal to 4 minus x1, or x2 is greater than or equal to 1 minus 0.25 x1, right? So that constraint, so, right, I'm going to have 1, and then a negative, a slope of -1/4, right, means that I'm going out here to the 4. So draw that guy in. That's good enough. Okay, so here, use green. So again, greater than or equal, so anything that's higher than that. Okay, there we go. So what's the point? So, again, you can clearly see, right, that this triangle right here, this triangle is useless, right? Because only the green here, only this constraint is satisfied in this area, and even though I didn't draw it very well, only the yellow constraint is satisfied in this area, right? So right now we're looking at an area right, that looks like that. That's where we're going to find our solution, okay? Well, nonetheless, we still, to find the actual area, we still have to do our third constraint. So let's do that. Okay, so this one looks a little bit easier, right? Because x2 is just greater than or equal to 3 minus 3x1, right? So that one, well, that's pretty easy, right? So we're going to start off here at 3, and then, right, with a slope of -3, we're just going to go right down to a -1. I'm sorry, I don't know why I said that. We're just going to go right down to 1. And, okay, there we go. And then draw this in. Guess we'll use blue, right? So here, you can already see, right, it's going to be this area here. Guess I'll just kind of draw that in, right? I'm not going to confuse everyone and draw all this in, because you can already see that what area satisfies all three constraints. It's everything out here, right? So I'm going to do the trick that I learned from the last class and get this. Okay, so what area are we talking about here? Right here, go this way. Okay, I can't see. Right, and then, so everything out here. So now, when I get my handy dandy eraser, there, perfecto, right? This is the area that I'm looking for, right? Somewhere in here is where I'm going to be able to minimize this function, okay? Now, one thing that always helps me is, I always think of like in the last video, we maximized profit. So I went from, basically this way out with my ISO profit line, right? I went out like this because I'm trying to maximize it. So, you think of starting off at 0, what's the highest level of profit I can get to? Well, the way that I see this is now I'm going to minimize it. So I'm going to start off here, right, and work my way down and try to find the smallest level of cost that I can find, right? And I do need to do one thing, because this got blurred. So I want to apologize for that. So I'm going to get a new color. I think I'll go with our purple again. There are 2 kinks. I kind of lost there is a kink. Yeah, there was a kink right here. So let me just color that in. And then this kink you can still see. My apologies. The pen was too fat, and I lost a kink there, but there's a kink here and a kink here. Okay, so with all that said, here's the idea. So again, I just want to draw this for you. Some of you probably already know, hey, forget that, just solve your 2 kink points. But let me just kind of show this to you. So again, I'm going to take 12x1 plus 42x2 equals some number, right? And then solve this for x2. So 42x2 is equal to c minus 12x1, right? So x2 is equal to c divided by 42 minus, let's see, 2 goes into here 6 times. 2 goes into here 21. Yeah. 3 goes into here 2 times. Oh, geez, that was stupid. 3 goes in there 2 times. And 3 goes into here 7 times. So there you go. So here, what I would do, right, is I would start off with a C of like 84. I guess like a C, C of 84. Right, because then that would give me 84 divided by 42. That means I would be somewhere, I'd start off here at 2, right? and I would have some line, it's going to have a negative 2/7. What are you doing? Right? That would be, this is what we call our ISO profit line. And the idea here, of course, is I just keep lowering C, right? Just keep moving this ISO profit line in this direction until I hit one of these kink points, okay? All right, well, we already know from our previous discussion that what we need to do is find out what these two kink points are and then plug those kink points into our objective function and now in this case, find out which one returns the smallest number. All right, not a problem. So, get rid of all this stuff. Okay. All right, so let's take this one right here, and boy, oh boy, I should have colored these because now I can't remember which two lines create that. Oh yes, I can. So this is going to be the blue, right? And then I gotta look at my notes. That's the 1.5. Okay, so that was the first and third. My apologies. So I'll do this. I'll do like kink point 1. This is the first and third, right? This is where the first and third constraints intersect. So, if you guys, so how do you do this, right? If you guys remember, what you want to do is, insert one of these equations into the other one. So, for example, this first equation can be written as x1, right, is equal to 3 minus 2x2, right? Now, again, I put the equal sign because this is where the first constraint equals the third constraint. So what I can do is just plug that x1 into this constraint. So I would get 3, oh, Kirk. So instead of x1, 3 minus 2x2, right, plus x2 is equal to 3. So I'm going to get 9 minus 6x2 plus x2 is equal to 3. So what I would do, I've got a negative 5x2. I'd move that over, right? So I would have 6 is equal to 5x2, okay? Or x2 is equal to 6/5, right? So this x2, right, is obviously, I don't have this drawn very well, but that would be, no, I do. I'm crazy. Little over 1, so that would be the x2. So then I can take this x2 and just plug it into any, either constraint. So I'm going to make this easy on myself. And I'm going to plug it into the third constraint because now I have 3x1 plus 6/5 is equal to 3. Multiply both sides by 5. 15x1 plus 6 is equal to 15, right? And then move that over. 15x1, that's 9. Right? Therefore, x1 is 9 over 15, right? And so actually I did draw this pretty well, right? At least that's less than 1 and that's more than 1. So, hey, not too shabby. Okay, so point 1 is 9/15, comma 6/5. All right. And I got point 1 done. Okay. And now I got to find the second point. Okay, so the second point, that is first constraint with second constraint, okay? So first constraint, second constraint. So, look, this one's actually pretty easy, right? Because x1, x1. So from this one, I can just say, look, x1 equals 3 minus 2x2. Okay, plug this into that one. So 3 minus 2x2 plus 4x2 is equal to 4. Okay, so that is a 2x2. I'm going to move that over. 2x2, right, is equal to 1. So x2 equals 0.5. Okay, so sure enough, I'm under 1, so that looks good. And now that I know what x2 is, I can plug that x2 into either of the constraints that I'm using, right? Constraints 1 and 2. So I'm going to put in the first one, right? So I have x1 plus 2 times 0.5 is equal to 3. So this is 1, right? So x1 is equal to 2, right? This is 1. Subtract that from both. Ooh. No, I actually got it. No, that's right. Let's see. I get so discombobulated. Yeah. x1 is a 2. So that's not perfect, but, you know, drawn by hand, I'm not going to complain. So this point here is 2.5, right? All right. Okay. So now what I need to do is plug both of these points, right, into my objective function. And in the interest of time, I'm already going to tell you, I've already done this. This guy doesn't work. This is the point. So I'll just move right to that. So I'm going to have 12, right, times 2 plus 42 times 0.5. So this is 24 plus 21. I get 45. Yes. Right. So my costs, right, are minimized at the point 2.5, and my total, right, the 0.2 comma 0.5, and my total cost would be $45. All right. And I will let you, should you so desire, plug this point into your objective function, and you will get a number that is greater than 45. All right. Well, at any rate, there you have it. Here is a minimization problem solved graphically. So we just have one more lecture like this, and again, I just want to show you what it looks like when we can't find a solution. And I should note that what we mean by finding a solution is finding a unique solution. In other words, there is only one point that minimizes, or if you think back to our last video, only one point that maximizes your objective function. That is the goal. All right? All right, well, with that, we are done with Lecture 3. I will see you in Lecture 4.